is on normal distributions. So we talked about some important distribution functions the other day. We talked about uniform distribution, skewed right, skewed left. We talked about, what else? Standard, what did I do? Uniform. Oh, the symmetric. So this is a type of symmetric distribution called the normal curve. All right. It's also known as the bell curve. So the normal curve or bell curve. This is used for just about everything in real life. If we want to find the probability that someone scores at least a 700 on the SAT math, or to find the percentile score, or to find the probability that you will grow to 68 inches if you are only a certain height when you're 2, right? All of these things are based on the bell curve. So it says in the standard normal bell curve, this is the one that you guys have a giant chart for. Do you guys see the giant chart on your notes? This. You have to memorize every number in that list. Just kidding. Just kidding. All right, you don't have to memorize every number in that list. That will be given to you on your test. But for that list, the mean is 0 and the standard deviation is 1. So that's what makes it the standard table. Okay, the standard normal bell curve. And it helps us to predict probabilities for real life problems and so on. So we're going to use this table a lot today. Okay, so it says suppose the mean of the data is 0 and the standard deviation is 1. Calculate the following probabilities. So the standard normal bell curve will always look like this. You'll have some kind of curve, called the bell curve. Most of the population falls in the middle, and then there are some outliers on the ends, right? And in the very center is our mean. So for the standard normal, our mean is 0. We want to know the probability that x is greater than 0. So any point on this curve is greater than that 0. It would be right here. So think about it. We've done a lot with geometric probability. What do you think the probability is that we're on that right side? It's 50%. Does that make sense? It's going to be half of the probability. It's 50%. And if you were looking for this on the table, you would just go along the, we call these z-scores, along the left. And our z-score in this case is 0. We're saying greater than 0. So what your chart does is it tells you everything up to the z-score. So if I have a z-score of like 1.62, what you would do is you would go down to 1.6, and then you would go over to 0.02. Do you see that? It would be this number right here, which is 0.9474. Do you guys all see that? Look for that on your table. So look up 1.62, like z equals 1.62. It would be right here, 0.9474. Do you guys all see that? What that means is that's the probability that you would get up to that z-score. That's the area under the curve, basically, the probability that you're going to be there. Okay, the whole curve would be 1. All right, so in our case, we just had 0, so we looked it up, and it was 0.5. So this probability is 0.5. Okay, so the next one says, well, what's the probability that x is bigger than 1? Well, our mean of 0 is in the middle, so x equals 1 is on the right of it, just like a number line. So negatives are on the left, positives on the right. So we're going to be on the right side. So we're going to go to our table, and we're going to look up 1. So on my table, if I look up 1, 1.0, and then I go over, see how it's 1.00? This is my probability right there, 0.8413. So think about it. We want 0.8413. That means it's 84% of the curve. Is that what this is? No? Why do you know that, Yaya? You're right. It doesn't look like it. It's already smaller than half, right? How's it going to be 0.8413? What do you think the 0.8413 is? Yeah, Alex? 84% on the other side, right? Does that make sense? So this is your dividing line, your 1, and you decide, is that 0.8413 on the left side or is it on the right side? And in this case, it's right here, 0.8413. Okay, it's the left part of it. Does that make sense? Because it's more than 50% on that side. The rest has to be smaller. So what do we do to get the rest of it? Subtract from 1, yeah. Chloe?
What is the, like,
What's the what?
I don't understand, like, what is it?
It's the probability that you would be in this area right here. So I'm going to get 0.1587. That's the probability that I would land in that shaded portion. Okay, the other part was the 0.8413. All right, so these ones are the kind of tricky ones when there's tails. So let's try this one. So we have the mean in the middle. We have negative 1.2 on the left. We have 1.5 on the right. We want the probability that we lie in between negative 1.2 and 1.5. Okay, so we're going to look some things up on our table. Okay. I want to look up a negative 1.2, but if you notice for your table, so flip to it, you don't have any negatives. So let's look up the positive one. So let's look up positive 1.2. So I'm going to go down to 1 point something. So I have 1.2, and then it's 1.20, so it's this one right here. So 0.8849. Okay, we think to ourselves, if I have this as my dividing line, and I'm thinking about the left and the right side of that, what's going to be 0.8849? The left side or the right side?
Left side.
The right side. Right, it's going to be everything from here over. It's going to be that.
No, why are you going to look at it?
Because we looked up the negative 1 point, or we looked up 1.2 in the table. So this is the 0.8849. That's the number, right? 0.8849. All right. Well, what if I look at the other one? What if I look up 1.5? So yeah, you're saying, well, we didn't look up that one. Let's go back. 1.5. 1.5. 0.9332. So 0.9332. And then we're kind of stuck. We're like, I just want that part in the middle. I have 93% on the left of 1.5, and I have 88% on the right of negative 1.2, but I don't really know how to do the middle. Yeah. Can't do the average. That'd be nice. That'd be if they were perfectly symmetric. What can you do? Add them? No. Subtract from what? All right, let me give you a hint. What if I want to find this? I call this a tail. Yep. Well, kind of. So what I'm going to do is I'm going to find this tail over here. You can't quite do that, Emily. That's not quite right. Okay, so I'm going to do 0.9332, and I say, well, what's the rest of it? That was 93.32% on right here, but what's the tail part? Okay, so I do 1 minus it. When I do 1 minus 0.9332, I get 0.0668. That's just in the tail right there. So let's find the other tail as well. So its tail is going to be 1 minus 0.8849. So it's going to be 0.1151. Okay, now that you have the tails, can anyone tell me what to do? So my probability is going to be 1 minus, subtract the two tails, 0.1151 minus 0.0668. So I've done a lot of this without a calculator. I'll show you how to do the subtracting from 1 without a calculator. This time I'll let you use a calculator. You don't have to, though. You can still do it by hand. All right, so when I do this, I get 0.8181. That's my probability that I'm in the middle. And it should make sense based on it, right? It looks like it's a lot. It's not like smaller than 0.5 or anything. All right. Okay, now the way that I'm subtracting in my head, this is a very convenient trick to have in this section. Okay, so if I have, like this one that I just did, right here, 1 minus 0.8413, that one. The trick to doing this with mental math, guys, look, everybody look up here, is I want a number to be added here to get 9, I want to add to get 9, I want to add to get 9, I want to add to get 10 at the end. Okay, so here's what happens. So if I add to be 9, I'm going to have 1, 5, 8, but then I want the very last number to add to be 10. So I get a 7, because what happens is this becomes 0, I add a 1, that becomes 10, I add a 1, this becomes 10, I add a 1, this becomes 10, I add a 1, right? It makes 1 when you add them. So on this one that I just did here, 1 minus 0.9332, I knew that it was going to be 0.0668, because I'm saying 9, 9, 9, 10 at the end. You see how I'm doing it in my head? So we'll be doing that a little bit. All right, so let's try the next one. So the probability that x is greater than 2.4. So the probability that x is bigger than 2.4, our mean of 0 is in the middle, so 2.4 is on the right side somewhere. It's pretty far on the right. Okay, so we have something like that. So I'm going to look up 2.4 on my chart. So everybody do that. So flip to your chart. We should all be trying this. So when I look at my chart, I go down to 2.4, and I go over. Right, so I have 0.9918. That's 99% of the curve. That is here, 0.9918. That's not the answer I want. The part that I shaded, I said x had to be greater than 2.4. So I need the other part. So what do I do? So I do 1 minus 0.9918. And when I do that, I get 0.0082. That's my answer.
So that's the
That's the probability that I'd be in that little tiny area.
0.82% chance.
Yeah, 0.82% chance, yep. All right, now all the things that I've given you so far have only used one decimal. We've only used this first column. Okay, but I told you that we will be using things that have other columns, like I talked about the 1.62. 1.62, I go down to 1.6, and then I go over to 2. That would be the 1.62, right? So these next ones use the rest of the chart. So we're saying, what's the probability that x is less than negative 1.18? So I always draw out a sketch. Every single homework problem you will have in this section will involve some kind of sketch. If you don't do the sketch, you will probably get it wrong. We want x to be less than that. So we're on the left part. Is this a number that's going to be bigger than 0.5 or smaller than 0.5? Smaller, right? All right, it's little. All right, so I'm going to look up 1.18. When I do that, I go to 1.1. I go over to the 0.8. So I'm going down, I'm going over. It's that number right there, 0.8804. Do you all see that? Okay. So I get 0.8804. So that's from here over, because it's more than 50%, right? More than 0.5. So my answer, what do? I do 1 minus 0.8804. Now, can you guys do the mental math stuff? You want your numbers to add to be 9, except for the very last number needs to add to be 10. So I have 0.1196. Perfect. All right, you guys think you can try number 6? Number 6 is a hard one. See if you can do it. Try it. All right, so here we go. So you guys did this, right? So you draw it out. On this one, they're both actually on the same side, right? Oops, what am I doing here? Okay, so when we draw it out, you have the mean of 0, and then both of these are on the right-hand side, 1.23 and 1.54. Oops, 1.54. All right, so when you look up 1.23, did you guys do that? What do we get? Yeah, 0.8907. You guys all have that 0.8907. All right, and what that represents is everything shaded up until you get to 1.23, right? It's more than 50%. That's the key. Just decide if it's more or less. So we have 0.8907, right? So that's this portion. All right, now we want to do 1.54. So when I find 1.54 and I look that up, that's even more, right? Oops. So 1.54 is going to be 0.9382. Okay, so how do I get that little blue shaded area? Yeah? You do subtract the two numbers. You do 0.9382, and you subtract out 0.8907. That is correct. You may use your calculator if you would like, or you can subtract by hand. It doesn't matter. So 0.0475 is your answer. Okay, why did I not need to find the tails in that case? Do you guys notice that you don't need it? Yeah, Jenny? Yeah, they're on the same side. So really, like, you have the full area was the 0.9382. If you just subtract out that smaller one, see how you're left with the shaded region. Okay, so that was easier. You could find the tails, that would be fine, but you don't really need to. All right, so next up. So obviously in real life, we don't say that the mean is always 0 and the standard deviation is always 1. Yes?
Like, why is it always 10 to 0?
The mean is always 0 in order to use the chart. We need the mean to be 0 for the chart. Okay, so that's what I was kind of saying here. So the mean is not always 0. Okay, if I asked you the average height of all the men in the world, is their average height 0?
Yeah.
No, it's not. Their average height, I don't know, like 5'10", 5'11". That's probably the average height of men around the world. So we don't have an infinite number of like bell curve charts with different means and standard deviations. It just doesn't work that way. We always have to use the standard table. Okay, so in order to do this, we need to change everything into numbers that are on the chart. Okay, so these are going to involve what we call z-scores. So z-values or z-scores. So it says if the mean is not 0 and or the standard deviation is not 1, you have to change your graph to fit the normal bell curve. It says the z-value of the value x in a data set with mean, mu, and standard deviation sigma is z equals x minus mu over the standard deviation. So x minus mu over sigma. X minus mu over the standard deviation. This formula will be on the bottom of your bell curve chart, your normal curve chart that I give you on the test. It will be on your test. Okay. So it says, as the SAT is used for college admissions, the GRE is used for grad school admissions. So when I went to college, I had to take the SAT. When I went to grad school, I had to take the GRE. It's the same thing like the SAT. I mean, it's harder, obviously, but it is math and English. Same idea. So verbal and quantitative. So a sample of verbal scores and quantitative scores from the GRE are both normally distributed with the means and standard deviations given below. So let's say Natalie, so one of you Natalies, takes this test, and she scores a 610 on the verbal section and a 700 on the quantitative section. It looks like she did better on the math portion. Yay. Good job, Natalies, for doing well on your math section. But we're actually going to find out that when we do this problem, she actually did better on the verbal section. Okay, because it matters what the mean and the standard deviation is. It matters how well everyone else did, which is weird. All right, so we have x equals 610. So this is for verbal. We'll do verbal first. Our mean for the verbal is right there. It's 470. And our standard deviation is 121. So if I was drawing out the curve, I have the mean is at 470. So she's on the right side of the curve, right? That's good. She scored better than average over there. So we want to find the percentile. We want to find the percent of people who scored less than her. Okay, so we do this by using our little chart. But we can't look up 610 on your chart. If you look back at the chart, you will see your chart only goes up to 2.9. And when it goes up to 2.9, that's almost 100% probability. Whoops, I don't know why it's all off there. It's right there, right? Almost 100% probability. So putting in 161 or whatever, or 610, I don't know where I got 161. Putting in 610 is way off the chart. It's not going to work. Yeah, so we need to somehow change it to what we call z-scores. Okay, we need to change them to numbers that are on the chart. So we do this with the z equals x minus mu over the standard deviation. So I have 610 minus 470, and I divide by 121. So 610 minus 470 divided by 121. When I do that, I get 1.5 or 1.15702, blah, blah, blah. How many decimals should I keep? 3 usually in this problem. 2. Why do you say 2, Chloe?
Because
The chart only has 2, right? So we're going to use 2. So we're going to make it 1.16. We're going to round up. So you round however it would round. If it rounds down, round down. If it rounds up, round up. So we're going to look up 1.16 on our chart. So I get a 1.1. And then I go over to 1.16. So I get 0.8770. That is the blue shaded region.
good.
So she scored better than 87.7% of people. So her percentile score, we say it's the 87th percentile. We don't round up, isn't that sad? You kind of want to say it's the 88th percentile because it looks like it rounds up, but she's in that percentage point. She's in the 87, like between 87.0 and 87.99. Yeah. So when you get the I step back when you got it when you were in elementary school and it said you scored in the 99th percentile, that meant that you scored better than 99% of people that took that test. Yes.
So is that like the same as like when babies go in for?
Yep. Growth charts. Yep. Yep. When I take my boys in to see how they're growing, my boys are always like over here because they're humongous. But if I'm talking about their height, then it's above the mean, right? Does that make sense? And then they can put it on an exponential chart to see where they will grow. Yeah.
Then what does it mean if they're like off the charts? Because like my little sister, she's super tall, and so she's like off the charts for height.
Yep, that means that they're an outlier. Remember I used the word outlier the other day? Yep. So there can be outliers as well. All right, so whoops, don't flip yet. So we still have to do this for the math one as well. So let's do the math. Do the math. Ha ha. All right, so x for math is 700. Mu for math is 550. And sigma is 148. So again, I have some kind of curve. Whoa. And I have my mu is 550, and she again scored better than the average at 700. But now when we do the z-score, so x minus mu over the standard deviation, we have 700 minus 550 over 148. We get 1.01. All right, so we have 1.01. And now when we look at this up on our chart, if we go to 1.01, go to 1.0, go over to 1, so 0.8438. That's that area there. What does that mean for her percentile? The 84th. So she actually kind of did better on the verbal, right? She got a higher score on the math, but comparing her to the rest of the population, which is probably what college admission offices would do, compare you to all the other applicants, she did not do as well. All right, so let's try some other ones. So it says a normally distributed data set has a mean of 74 and a standard deviation of 8. Find the probability that a data value chosen at random is between 66 and 78. I always have you put the mean in the middle, so mean is 74. That way you can say, oh, 66 is on the left, right? So x equals 66 and x equals 78. I don't use a z until I change them into what I need them to be. Okay, these are just x values. X, you cannot look on the chart, you need z's. So z is x minus mu over the standard deviation. So I need to find it for both of these. So I have 78 minus 74 over standard deviation was 8. So I get 4 over 8 is 0.5. So the value on the right has a z-score of 0.5. Are you allergic to algebra? Lots of sneezing. All right, statistics. Yeah, makes me sneeze too.
What?
Statistics, I'm allergic. Huh? AP Stats does a lot of this, yeah. It's not hard. It's boring. Don't tell Maury that. Uh-oh, it's being recorded. Shh. All right, so I have 66 minus 74 over 8. I'm sure he makes it fabulous. All right, so negative 8 over 8 is negative 1. All right, so that z-score is negative 1. So when you're asked to find the probability that x was between 66 and 78, what you're really doing is finding the probability that a z-score is between negative 1 and 0.5. You don't have to write out all of this fancy, like probability of this, probability of this. I don't care. Just write the answer. I'm cool with it. But if you want to write that, you can. So how do I find this answer? What am I going to need to find in order to find the part in the middle? I gotta find the number, the probability, and then I'm gonna have to find those tails. Do you guys remember the tail thing? We're gonna do that again. So I'm gonna plug in, so I'm gonna find -1, so I'm gonna look up 1 on my table. So when I do that, I get 0.8413. And then I'm gonna look up 0.5 on my table as well. So when I look up 1, I get 0.8413. So that represents the part on the right side of -1. Makes sense? It's more than 0.5, 84%. Okay, so that means its tail is 1 minus 0.8413. So what's it going to be? 0.1587. Do you guys remember that? 99910. All right, and when I look up 0.5, I get, is it 0.6915? Yeah? So I look that up. So when I find its tail, it's going to be 1 minus 0.6915, which is 0.3085. So my total probability is going to be 1 minus each of those tails. 1 minus 0.1587 minus 0.3085. So I get 0.5328, and that's your answer. Yeah. All right, does this make sense? So you were going to do this for every single one of the problems. Now these problems do get more, I don't know, story problem-esque. So it says things like, a radar unit is used to measure speeds of cars on a road, right? What's the probability of a car traveling at more than 95 miles per hour? Or I think there's some like about how long it takes for a fire truck to reach your house if there's an emergency. What's the probability of them reaching there on time at 90% of the time or something? So there's lots of different problems that would involve normal distribution. So I'll finish this section on Monday. So your homework is not due until Tuesday. Yes, do you have questions? I would start on your homework though. Don't wait